This is R.D. Sharma Solution, Class 12, Chapter 6, Determinants, MCQ, Multiple Choice Questions. Now, in the MCQ, there are always 4 options, and we'll choose one of it. And in some cases, there may be more than one they are true. So, if A and B are square matrices of order 2, then determinant of A plus B is equal to 0 is possible only when. So let me tell you, the answer is a D, and this is quite obvious. Why? You can do all way to interpret it and to analyze and show it, but when we have A and B and when we add them and then we take the determinant of it to be 0, that is only possible when A plus B is 0. If A is 0, B might have some value. If B is 0, A might have some value, right? So, getting together A and B, when it adds up, then if it is 0, then only the determinant of A plus B has to be 0. It will be equal to 0. If both are zeros, then also 0. If one is A, say B is equal to minus A, then also the thing remains same, A minus A 0 or B minus B equals 0. So here the logic goes that A plus B, this has to be equal to 0, then only the determinant of A plus B equals 0 is possible. Now you can understand it like this also. You can have A and B different square matrices of order 2, and when you add this and then take the determinant, and if a determinant is 0, that means this Aij plus Bij equals 0, and that means it has to be 0. Addition of each element has to be 0. Which of the following is not correct? So let me tell you, the answer is D, because it is not correct. The others are correct. So first let me understand or make you understand the D one. So when we open it, it's just not A plus B can be written as just all these addition can be divided into 2 matrices. It's not like that. You have to open it 4 times. So A plus B, E plus F, C plus D, G plus H. So how are we going to open this? This is only possible when we do AE separately and then BF separately. Rest will remain same. C plus D, G plus H will remain same. C plus D and G plus H will remain same here. Then now we have to open this C plus D and G plus H. Same logic goes. A C C G and AE C G and AE DH. So this has to be opened into 2, AE DH, and the next one also BF and CG and BF and DH. Okay. So this is incorrect. Now A and A transpose, if you take the determinant of A or A transpose, they are same, right? They are same. Rows and columns are only changed, so determinant will not change. Determinant is actually the value of that matrix. We already saw that Ka, when we take K outside, it will be K to the power n. Since this is 3 by 3 matrix, it is K raised n, and then we have determinant A inside. Third one is, if A is a skew symmetric matrix of odd order, then the determinant of A is 0. So odd order, if the matrix is of odd order, then the determinant of A will be 0. Now A is this matrix and Cij is the cofactor of Aij in A, then the value of determinant of A is given by. So A11, C11. Always remember, the cofactor of A11, that is the C11, is multiplied to the value. But others are A11, C31. No, it's incorrect. Only B and D seems to be correct. But still, A12 cannot be with C21. It has to be with A12 and C12. So the D1, A11, C11, 2121, 3131, this is correct. So the answer is D here. Please remember, the subscript has to remain same. For example, A11, the cofactor is C11. For A12 it has to be C12. A13 it has to be C13. Okay. Now if one more thing, let me tell you, if we take the row and the cofactor of the other row and then you apply this, it will be 0. So cofactor of another row or a column with that row or different row will be 0. Which of the following is not correct in a given determinant of A, where A is equal to Aij and this is 3 by 3 matrix? So which one is not correct? Now the answer here is B. Minor of an element can never be equal to the cofactor of the same element. See, minor and cofactor, they are just equal with the sign. What I am trying to suggest is cofactor is just a minor with this sign, and the sign depends on -1 to the power I plus j. I plus j is the I and j are the row number and the column number. Okay, so the minor of an element will be equal to, half of the minor will be equal to half of the minor will be equal to cofactor, half of the minor will not be equal to cofactor because there is a slight change in the negative sign. Okay, so if you take a 3 by 3 matrix, wherever we have -1 to the power even, then minor and cofactor are same. Whenever we have -1 to the power odd, I am talking about I plus j, row number and column number. When it is I plus j, when it is odd, then the minor and cofactor will not be equal. Only the difference will be the negative sign. Minor will be equal to negative of cofactor and vice versa. Now coming to the first one, order of minor is less than order of determinant A, and this is absolutely correct. Value of the determinant is obtained by multiplying elements of row or column by corresponding cofactor. This is also true. We have just seen in a previous question. So we take the row and we take one by one the cofactor of that element of that row or a column. Okay. Now order of minors and cofactors of elements of A is same. Order of minors and cofactor of the element A is same, and this is same because minor cofactor has no change. Only the signature is that is a sign is same. Let this is an expression or you can say an equality. Then the value of 5a, 4b, 3c plus 2d plus e. So we have to find out the value of a, b, c and d and e. If we are able to find out the a, b, c, d, e value, then we can apply it here, use it here, and then we can find out the value. So since we have an equality, we'll open this left determinant and then we'll try to equate it with the right one, and then we'll equate the x to the power n coefficient with the x to the power n coefficient on the either side. We'll equate that. So either you take the left one and try to put some properties and solve it, or you can just open it. So when you open it, see, you can easily get first column, second column subtraction, first column, third column subtraction, or the rows first, second, third. You will get various zeros. But rather than going to the detail, because this question is a bigger one, so let us open it using the first row. What do you get? X. What will be the minor here? X6, X6. Two rows are same, so it will be 0. Then -2, it will be x square x and 6, 6. X square x and 6, 6. Okay. Then we have the third one plus x, and then you get x square x, x, x. X square x, x, x. So what is this? 6x minus 6x, it is 0, leave it. This is 6x square minus 6x. Then you have -2 outside, plus this will be x cube minus x square. So we have x cube minus x square it will be. So let us open it. -2. So -12x square plus 6 to the 12x plus x to the power 4 minus x cube. Now let us arrange it with the descending power of x. So x to the power 4, you write it here, x cube, so it is minus x cube Then we have minus 12x square. So write minus 12x square. Then you have 12x plus 12x plus this is 0. A is 0. So A is x is A. So 1 coefficient is 1. B is minus 1 and C is 12 and D is 12. C is minus 12 because it is minus 12 here. It is minus 12. So let me just change it. It is minus 12. So C is negative 12, D is equal to 12 and E is of course 0. Now you have A, B, C, D, E value. You all got all value you have got. Now 5 into A, that is 5 into 1 plus 4 into B, B is negative 1. C into 3 into C, C is minus 12, negative 12. Then 2 into D, D is positive 12 and E of course is 0. So this is going to be minus 11. The value of the determinant is independent of. So it may be independent of n or x because A is a constant. There are only two variables x and n. So let us open it properly. And then before that, assume this, say nx to be A. Nx to be A, n plus 1x to be B, n plus 2x to be C. So you have A square A1 cos A, cos B, cos C. Sin A, sin B and sin C. Right? So let us open it. And there will be an expression you need to remember, that cos A sin B minus cos A sin B minus sin A cos B is equal to sin A minus B. So I am just opening it, A square using the first row. So you get A square cos B cos C sin B sin C minus A. You get cos A sin A. Then we have cos C sin C plus 1. And this will be cos A sin A and cos B sin B. Okay. Now this is A square cos B sin C you can write, minus cos C sin B you can write, minus A cos A sin C minus cos C sin A plus 1 into cos A sin B minus sin A cos B. Cos A sin B minus sin A cos B. Okay. Now we have an identity, we have an equation here. So this equation is cos B sin C minus cos C sin B. Just assume that it is say cos A sin B minus sin A cos B. So it is sin A minus B. Please remember. So since we have B and C here, or C and B here, so you can write it as sin C minus B. So A square sin C minus B. Second one will be minus A sin C minus A. This is sin C minus A plus sin B minus A. So sin B minus A. Okay. Now, we have assumed A, B, C. Now we have to subtract it. Let us see C minus B. What is C here? C was n plus 2x. What was B? It was n plus 1x. So C minus B is n plus 2x minus n plus 1x. So you can take x common, n plus 2 minus n minus 1. So n gets cancelled, 2 minus 1 is 1. So you get x here. So n is not there, remember? And please, try to see that there is no n here. Similarly, C minus A will give you 2x. B minus A is going to be x. Just subtract these because we already assumed it. So I'm just subtracting is n plus 1x minus nx. So when we have n plus x minus nx, it will again be 1. Or you can say x. Again, the n is not there. In all of these, you'll get a square sin x minus a sin 2x and this sin x. So finally, we can conclude by saying this, that this is actually independent of n. There is no n here. So what will be the answer? The answer is A. This is the answer. Now we have two determinant, and these two determinant, there are certain things which are given. Adding of these two gives 0, 1 is equal to 0, or 1 plus twice of second is equal to 0, or none of these. What we'll do here is, because we have already done this type of question while we were doing the exercises, and this second one you take and see, this second one we have already done, so I'll just show you how we can make it as the first one. So I'm just writing it 1 1 1 BC CA and AB. Then we have ABC. So ABC multiply ABC divide. So I am taking A, multiplying it with the first row, B multiply with the second row, and C multiply with the third row. So in the first row we get A, ABC and A squared. Multiplying this with B now, second row with B, B, ABC and B square. Multiplying this with the third row. So what do you get? C, ABC again, and then C square. Now let us take ABC common from the second column. So already ABC was in the denominator, so just cancel it. So you get ABC 1 1 1 and A square B square C square. Now just change the column 1 to column 2. It means exchange column 1 and column 2. And we remember always that when we exchange two rows or two columns, that means we have a negative sign outside. Column 2 and column 1 we are exchanging. So 1 1 1 ABC A square B square C square. So this negative was there. Now since these two are still not same, but we know that the transpose can be done. If the rows are changed into column, that is A transpose, if we take the determinant, then when we equate it, so the determinant of A is equal to the determinant of A transpose, right? So now you can just transpose the rows and column. Since negative sign is already there, 1 1 1 this column I'm making it as row, ABC I'm making it as a row, A square B square C square I'm making it as a row. Okay. Now negative sign I'm putting it in front. So what do you get? Since determinant of 1 we can write directly write 1A 1B 1 1 1 ABC A square B square C square, and these two are same. So you subtract it is going to be 0.